More JavaScript! Hey, in the last part we broke free from the command line, opening up all kinds of new possibilities. In this part, we're going to learn more features of JavaScript that we can use to bend Minecraft to our will. But first, debugging. When you're writing code, inevitably something is going to go awry, and JS Hint can help you catch certain kinds of errors, but there are many others that it will miss. And one way to debug is to try things out in Minecraft on the command line. You can just type in some code in there. We've been doing that all along, JS something or other, and see if that works. But another tool that we've got in our toolbox is echo. We've seen echo before. Echo is really useful because you can put echo statements wherever you are if you think something is going wrong. So let's take a look at this in action. So we've got this myCottage function that we've worked on before, and let's say that we had a typo here. Right now it says prism 0. Let's say we had accidentally typed prismo. Now that's not going to work because that means that something's going to go wrong drawing the roof. So if we ran this, we'd see, oh, our roof is not drawing and neither is anything else going on here. So we can sort of verify that that's what's going on if we type a semicolon there to basically stop that drawing. And then we add an echo because echo is not part of what the drone offers. So echo, we have to separate from our drawing. So we say echo, I think there's something up with the roof. Okay, and then you can see that this is actually the wrong color, this prismo. That's because it says .prismo, and that's sort of just hanging out in space. You can't really start a JavaScript statement with dot. And that's because we need to call prismo on the drone, and we can get access to the drone by typing this, just like we do at the beginning of the function. So we call this again, or we say this .prismo. And then we'll add another echo statement here, saying, did the roof draw? So that's basically going to verify, this is going to verify our assumption. We're assuming something is going wrong with the roof. We don't know what's going on. So, oh, whoops, I missed a semicolon. Oh yes, I missed a semicolon on this line. Now remember, there's a comment at the end of this line, and this kind of comment is going to go through the end of the line. So that means we have to put the semicolon before the comment. Okay, so now we successfully have that statement closed off. Let's go over to Minecraft and try it out. So we refresh. Okay, and then we do up.myCottage. Okay, and so it's drawing my cottage. Oh, and it didn't actually make it to the roof. You can see, I think there's something up with the roof. It got an error, and then it actually didn't go ahead and draw the roof. Now, usefully, it did actually tell us undefined in eval line number 26. So line number 26 actually could be considered this entire statement here, which is indeed where we think the problem is. And so this is giving us useful information. So we go to line 26. We know that there's something up. We know that it's printing this statement, and it's not printing this statement. So there's something going wrong in between. And now, of course, we know that it should say prism 0. Let's see, let's get rid of this here. JS box blocks.err 756. I think that'll clear it out. Whoops, that gave us error. I actually wanted grass there, but oh well, no problem. So we have a hole in the ground. Okay, so we change it to prism 0, and now back in our game, if I refresh and try that drawing again, now we can see, I think there's something up with the roof, and did the roof draw? So it actually wrote everything we wanted, and it did indeed draw the roof. So this is a way to sort of verify that it's getting to all of the lines of code we expect it to get to when it runs. We can also use echo if we need to print a value along the way. Now that wasn't so important for myCottage, but I think in some of the things we're going to be doing next, being able to print a value along the way is actually really handy. Okay, that's enough about debugging for now. Let's see about adding some commands to Minecraft. That's something new we can do. So Minecraft has these commands that start with, Scriptcraft adds these commands /JSP gives you special commands that basically don't interfere with normal Minecraft commands. And one of them is spawn. We can use that as an example. So I can say spawn cow. If I look around, there's a cow that I spawned right there. Looks kind of confused because he's wondering how he got there. I can try it again, spawn pig, and there's the pig. So you can just, they can just come out of there like that. We can define our own commands. So let's go and make a file for that in Scriptcraft plugins, new file, mycommands.js. Okay, and we're going to need a couple of globals for this. Whoops, no space between the star and global. Require echo and command. Okay, so command is a global. That is a global function Scriptcraft gives us, and it allows us to define a command. We're going to make a command called hi. And the command itself is going to be a function that is called when you run that command. Now remember when we were calling drone functions, we would pass in arguments to those functions. For example, we'd pass in what kind of block we want for a box, that kind of thing. So when you're making a function that's going to take arguments, you type in the names of the arguments here. Now a command function for Scriptcraft takes a parameters argument as the first one and a player argument as the second one. So parameters is going to be an array. We talked about arrays being lists that we can access. So parameters is a list of different options that the user typed in when they typed in their command. And then player is going to be the player object, and there's all kinds of interesting things we can do with that. So we'll say var salutation equals parameters. Now we want to get the first thing off of this list of what the user typed in. We use the square brackets for that, and we say 0. So arrays always start with 0 in JavaScript. So we say square bracket 0, close the square brackets, and that gives us what the user typed in as the first thing. And then we can say echo player. Now that's an interesting thing. Echo actually allows you to pass in a player object as the first argument to echo. You can either pass it a string that it just prints out to everybody, or you can pass in a player object and it will only show what you're echoing to that player. So we will say salutation plus. So you can actually add strings together in JavaScript using the plus operator. So we say salutation plus a space plus player.name. Okay, so that's going to basically display the player's name after our salutation that we type in. So let's save that and let us try it over here in Minecraft. JS refresh, call the refresh function, JSP hi, amazing, and it says amazing gremlin seeker, because that is what we told it to echo. Whatever that salutation is, if I said hi Mr., then it would say, whoops, JSP hi Mr., then it would say Mr. Gremlin Seeker. So it's a very simple command, and it didn't take us much to write. Now let's work on something more useful than that. So one thing Scriptcraft gives us is an object that we can access via this command line here that is called self. Self is a player object, and you can see it's my player object. So if I say self.location.world, that is actually going to be the world object. You can see it's a canary world object. So it's the world object of the world we're in. I wonder what we can do with that. Maybe we can say set raining to true. And look at that. It starts raining. And maybe I can set it back to false because it's kind of annoying when it's raining. So we can clear up the weather like that. That's pretty cool. We can clear up the weather just like that. But you know what? That's a lot to type every time you want to control the weather. So let's make a command that lets us control the weather. So over here in brackets, I'm going to make a new command. I'm going to call it rain. And just like before, it's a function. It takes parameters and player. Okay, so that's just like we had before. And I always seem to type that way. So we can make it rain by saying player.location, just like we did in Minecraft, .world.set raining to true. Okay, and if we do that, we have a command that will make it rain. And JSP rain. Now remember, all these scriptcraft commands, you start them with /JSP. Okay, and it's raining. Now of course, to turn the rain off, we have to actually type in that whole long thing that we did before, press up arrow. That's not quite as fun. So how can we make it so that the command for rain also lets us turn it off? Well, what we want is to make it so that there's a parameter to do that. So we want the rain to be on if there's this parameter passed in, but we don't want the rain to be on if it's not. So JavaScript has a keyword called if. And the way if works is you type in some expression in parentheses here, and if that expression is true, then it will go ahead and do the block of code that you put after it. If that expression is false, you can type in else, and it will do some other block of code. So what we want is we'll copy this and paste it in here, so that if something is true, it's going to turn off the rain, which we know we can do like this, set raining to false. So if something is true, we want to set raining to false, otherwise we set raining to true. So what we want is we want to look at parameters 0, and we'll say that if the user types in off, so they type rain off, then we'll turn off the rain. So we say parameter 0 equals equals equals. We sometimes call that triple equals. So in JavaScript, you use single equals to set a variable equal to another one, just like we did up here. Var salutation equals parameter 0. So 1 equals means set that value. 2 equals or 3 equals means to test the values. The double equals in JavaScript has some potentially confusing behavior. So a lot of people, including myself, just tend to use the triple equals form. It looks like a lot, but it works. So we say if parameters 0, triple equals off, then set raining to false. Okay, let's see how this works. So I refresh, and then I'm going to say JSP rain, and it will start raining. So now if I say JSP rain off, the rain clears up. So that is how you use conditionals. That is how you use do something, only when certain things are true. So far, everything we've been doing is before this if, all we had been doing was do this, then do that. Now we can actually say, if this is true, do this, otherwise do that. So it's actually a really much more powerful thing than what we've been able to do before. All right, so I'm going to switch back to my cottage over here, so we can talk about another thing. Another new idea along the lines of stretching beyond do this, then do that, is the notion of do this 5 times, then do that. Now, of course, we could just, copy and paste some code, and just repeat it over and over again. But say if you want to do something 100 times, that gets to be a bit much to type out, or a bit much to copy and paste. Or what if you don't know how many times you want to do something at the time you're writing this code? As an example, let's make a drone function called torch wall that creates a wall that has torches. And you'll be able to pass in the width and the height of the wall. So let's say function torch wall, and it's going to pass in the width and the height. Okay, and then we will set a checkpoint so we can put the drone back where it belongs at the end. We'll draw the wall itself to start with, blocks.stone, width, height, and since it's a wall, it only has a depth of 1. This dot move to wall. Okay. And then we need to add that to the drone. Extend torch wall. Okay, so we have this basic scaffolding here that gives us a stone wall with the width and height. But how would we add torches along this wall when we don't know how big it is? Let's first start by taking a look at what it would be like to add a single torch. So we'd say this dot up. So we're going to go up, and then we will go back, which means heading towards where you're standing. And then we hang a torch. And then we go back to where the wall is. And then we go back down so that we're back where we're standing. And then we go right so that we can do the next torch. Okay, so this is the basic way we would want to go and add a torch. But this is only going to add one torch. And we want to add torches all the way along the wall. So how do we do that? Well, we have a for loop to do that in JavaScript. So we type for, and then kind of like an if statement, we're going to have parentheses, and then we're going to have a block of code that we're going to repeat. And that block of code is this right here. Quick tip about brackets, I can select this code, and from the edit menu, there's an indent option, and there's a keyboard shortcut for that. So I can say indent that code, because typically all your blocks of code are going to be indented to make it easier to read and see where the blocks begin and end. So what do we put in this for in order to have it do this a certain number of times? Well, we start by putting in a variable, well, something that we want to initialize. We don't have to initialize something, but in this case, we do want to initialize something. We want to start with a counter, and we want to set that counter to 0. Okay, so we're going to have a counter that is going to move us along while we're doing this. So then we have a counter, and we want to check. Then we have something that we're going to check within every loop. So every time we go through, we're going to check and see, is that counter still less than width? If that's true, it's going to loop through again. If it's false, it's going to stop looping. And then finally, at the end of each loop, we want to run this little expression, which basically says to increment counter. That means to add 1. So counter plus plus is shorthand for add 1 to counter. So that is how we define our loops. And so what this is going to do again is going to set counter to 0. And then while counter is less than width, it's going to run through this and add a torch. And then it's going to increment counter again. So at some point, counter will then be equal to width, and it will stop. So imagine that counter is, or width is 3. So counter starts at 0, and then we check counter 0 is less than 3. That's our width. So yeah, we go ahead and add a torch. And then we increment counter, so it's 1. So counter is 1. 1 is still less than 3, so we add another torch. And then we add another one to counter. And then counter is 2, and 2 is still less than 3, so it adds another torch. And then we add another one to counter. And again, the width here is then, well, so counter is then 3, and the width is 3, and 3 is not less than 3. 3 is equal to 3. So it stops. And then it goes back to this part outside of the loop. So let's try it. Go back here. It's dark, but that's okay because we are going to have a nice wall of torches. So it's okay that it's dark this time. Up. Okay, so we now have a torch wall function on our drone, and we will give it a 10,3. Okay, so we have a wall that is 3 high and 10 wide, and it's got torches all the way along it. Seems a bit much, though, to have a torch all along the wall, right? Every single space has a torch. It looks a bit much, doesn't it? So we can make it so that you can actually space those torches out with an extra argument to the function. So let's say that we want to call that argument torch spacing. Torch spacing. Okay, so you can actually pass in how far between torches you want the torches to show up. Okay, so we add torch spacing as an argument here. Then what we need to do is we need to make it so that instead of going every single one, instead of moving by 1, we want that counter to actually move up by torch spacing amount. So if torch spacing is 3, we want it to add 3 every single time. So JavaScript has a shorthand for that too, and that's plus equals. So that means counter is going to be equal to what counter currently is plus torch spacing. So again, that means we're going to be counting by threes. Counter will go up by 3 if we pass in a torch spacing of 3. Another thing we need to do, though, is we also need to move right by torch spacing. So that way, when it's going ahead and adding a torch, it will then put back down to the bottom and go right by 3 instead of right by 1. And this should be all we need to do to be able to loop through and add a new torch for each. So for each 3 spaces. Let's take a look back in Minecraft. So I'm going to refresh, and I will do box. I'm just going to erase my wall. I don't really want a wall here. I don't want 2 walls here. Oh, okay. There we go. My torches are gone. Okay, and now let's try our torch wall. Torch wall 10, 3, and 3 for our torch spacing. And look, our torches are indeed spaced out as we said they should be. Okay, so let's take what we've learned here, for loops and if statements, and we'll see how it gets put together. A couple of quick brackets tricks here. There's a navigate menu, and one of the options on here is quick open. I use quick open all the time when I'm using brackets. If I know there's a module, I know that under drone contrib, there's the cottage module. This is the original cottage module. We can always go and open drone contrib and click on cottage. But if I want to do it from the keyboard, I just use the quick open function, which is Shift Command O on the Mac, Control Shift O on Windows, and I can just type in cottage. I can just start typing it in, and there is cottage, and I hit enter, and so cottage is open. Also under the navigate menu is quick find definition. That lets you jump to a function in a file quickly. So I happen to know that there's this actually really cool function called Cottage Road that I discovered only by looking in the cottage.js file. I didn't even realize this was here. I don't know how new it is, but it's pretty cool. Let's take a look at what it does. So back in Minecraft, I'm going to find myself a nice clear space, and I'm going to say Cottage Road. I'm going to call Cottage Road with 6. Okay, so it gave me some trees, gave me a road, and now it's building cottages along this tree-lined road. Now, of course, construction of a whole neighborhood takes a little bit of time, and that's what we're seeing here as it's building up. But this is pretty cool, right? And the neat thing about this is that this function works exactly like all the stuff we've been learning today. So let us take a look at the Cottage Road function. Let's see how that works. Okay, so it takes the number of cottages. So you give it how many cottages it's going to build. Now, type of is a special JavaScript operator that basically says what kind of thing is this variable. It could be a string, it could be a number. In this case, number cottages, it's checking to see. Remember I said double equals is to test, just like triple equals is to test to see if it equals something. So in this case, it's testing to see if the type of number of cottages is the string undefined. So undefined is a special JavaScript value that basically if you don't pass a number of cottages in, then it's going to just be this undefined value. And so what it's doing here is it's saying if number of cottages is undefined, it's going to set it to 6. So that way we know we've got a good number of values, or a good number of cottages, I should say. Then we set a variable, set a couple of variables that we're going to need. Distance between trees is 11. That's based on the size of the cottage and all that. Now this line here, you can see there's this call to math.floor. JavaScript comes with a bunch of functions on an object called math. A bunch of functions that are useful math functions. Floor is one of them. And what floor does is it rounds down. So if number of cottages is 6, then number of cottages divided by 2 is going to be 3, and that is an integer already. It's a whole number. It doesn't need to do anything to round down. If, on the other hand, number of cottages were 7, 7 divided by 2 is 3.5. And so if you just round down, you're going to get 3. Or if you chop off the 0.5, whatever is after the decimal point, you get 3. And that is what math.floor does for you. So the next part draws basically the road itself. And this is just normal drawing code like the kind we've been seeing. Okay, then we get to a for loop. So this is what we've been talking about today. And this Cottage Road function really wouldn't be possible if it weren't for the for loop. So this for loop doesn't have to initialize anything because I was already initialized up top to be 0. So what it's going to do is every time going through, it's going to, we had computed how many cottages per side. So we know that if you say 6, the number of cottages per side is going to be 3, because that's, number of cottages divided by 2. And what we do is we're saying if every time through the loop, we're going to check is I less than cottages per side plus 1. Because in this case, we wanted there to be, if there are 3 cottages per side, then that means it's actually going to draw 4 trees. Okay, and just like we saw, it's doing I++. I'll note that I is actually a common name for the variable that you use in a for loop. It's just sort of a tradition that's gone back for decades that people use I for that name sometimes. So all this is going to do is basically for each of those 4 trees, it's going to go draw 1 to the left, draw 1 to the right, and then move forward the distance between trees plus 1. And it does that, however many times it needs to in order for the number of cottages you've got. So next we have a little bit more drawing code, nothing unusual there. And then we find a function within our function. Now that's kind of different. JavaScript lets you do this. This is perfectly legal, and it's a nice way to sort of make something that you can reuse and do multiple times within a single function, but that's not available elsewhere. So the drone, for example, we couldn't add path and cottage to the drone function outside of here because this function only exists inside of the Cottage Road function. So the path and cottage function is actually pretty simple, though, what it does on the inside. It's given the drone object, and when it has a drone, it basically just draws a path to the cottage and the cottage itself. And that's all it does. Okay, but where that gets used is down here. We have another for loop. This sets I back to 0, and then for each cottage per side, it's going to do something to the loop. So it's going to do this. If we have 6 cottages in total, that's 3 per side. So it's going to do this 3 times. And it's going to basically do some drawing here. It's going to go forward, distance between trees plus 1. Now it's setting a checkpoint, and it's doing R plus I. Now this R is a string, and then I we know is a number. So that means that it's going to do R plus I is going to be R0 is the first time through. So it's actually going to be a string, R0. And then the next time through, it's going to do R1 and then R2. And each time it does that, it's going to call path and cottage, that function we defined up there that draws the path and the cottage. It's going to do it. You call that function to do it on the left, and then it goes back to that checkpoint we set. And then it does it on the right, and then goes back to that checkpoint that we set. So this is basically putting everything together that we've been doing along the way. So writing code like this takes practice. When you first use a hammer, that nail doesn't always go in perfectly straight the first time. But you know what? Because you know these things, even if it's difficult to write this kind of code, you know these things, and so you can actually read this code, and that will help you as you poke around inside the Scriptcraft code itself. And that's a really great way to learn some more JavaScript. You can poke around in the Scriptcraft plugins drone contrib directory, and you can see all the cool stuff like the castle. You can see how that works. The fort that actually is part of the castle. You can see how all these things work by looking at that code, and you'll have a better idea now that you've learned if and for, how those things work. And next time, we're going to learn more that Scriptcraft gives you that lets you do something completely different than what we've been doing, all this drawing with the drone. We're going to learn how to react to the Minecraft world on the next time. See you then.